error messages at them. And it's no wonder that at the end of the day, when we throw a real error message at some of our users, they just ignore it and they dismiss it. So this is the first problem. Going further to the second problem is the fate of many of the virtual websites today. There's approximately anywhere from 200 million to 300 million websites today. And it's been said that there's about 1 million of well-configured SSL servers. So what you'll find in real life is that you open a plain text communication channel to a particular domain name. You may get one website. And in the case of virtual hosting, if you open a secure communication channel to the same address, so the only difference is the small s in the URL, you will get a completely different website. So again, this is yet another of those confusing issues. So in many cases, for companies, this will be a branding issue as well, because what people are going to see is your domain name. And basically, it's a sort of a game of Russian roulette, because in a typical virtual hosting environment, behind a single IP address, there may be 1,000 websites. And you don't really know which one is going to show, because there can only be one secure website per IP address at the moment. That's a technical limitation. So it's a sort of a lottery to see which website, which presentation you're actually going to see under your domain name. So the important lesson here for companies that value their brand is to always go for secure web hosting. In that way, they will reserve one IP address only for their websites, and then preserve the integrity of their brand and not confuse their users. Very high on my list are the self-signed certificates, and all other certificates that are basically invalid. And this is you're not going to find it today on publicly facing websites, because the cost of certificates has largely fallen down. They're very inexpensive to buy today. However, you are going to find them on many hobbyist websites, and especially on intranets. And intranets are such a big part of our daily lives in big corporations anyway. And again, we are teaching our users that warning messages are all right. The important thing about self-signed certificates is they will throw a warning at you. And the thing is, you will get the same warning if you are using an insecure network and if you're being under an active man-in-the-middle attack. So this is the same warning. So imagine that you had to spend days and months accessing some sites internally, for example, ignoring warnings, and then you come to a conference like this. You're using a wireless network, not here because apparently they don't let you, but because it's insecure, you're under an active attack or man in the middle, and someone will actually see all the information and be able to forge anything that you do, but you will dismiss that warning. And that warning is the only thing that stands between you and security. And this is what you get. The connection is untrusted. Number 4 is not using extended validation certificates. Extended validation certificates are today what plain certificates used to be many years ago. Basically, if you want to apply for an EV certificate, you will have to go to a lot of bureaucracy to prove that you exist as an organization, and you have the right to use the domain name. Now, the EV certificates, some people view them as just a way of getting more money out of companies, because they are more expensive because of the added involved bureaucracy. But the point is that we're seeing many interesting new attacks against SSL. I've taken the example of PayPal.com. So they have an EV certificate, and they have a really nice green glow. So if you want to go to the PayPal website, if you see the green glow of the EV certificate, it's pretty certain that you're at the PayPal website. What's interesting, for example, is that it is now possible to use domain names with non-Latin names, so you can have domain names in Cyrillics. As it turns out, many of the letters in PayPal.com actually look like Cyrillic letters. So just as one example, letter P looks like letter R in Russian. So you can actually have a domain name that looks exactly like PayPal.com, but written in Cyrillics, and that will actually point to a completely different website. So if you don't have an EV certificate, you will, it will seem that you're like at you're at paypal.com, but in effect you will be at someplace else. So again, the EV certificate is the only way to prevent that. And there are many other ways, because there are many similar letters, even without having to go into non-Latin domain names. Number 5 is badly configured SSL servers. And it's only once you start to follow the results from the online assessment is that you realize how many insecurely configured SSL servers there are. Most people, I'm guessing, don't really bother with configuring their websites for security and performance. And it's really, it can be up to a 5 or 10 minute job. In the rating guide that we have online, there's actually a section on recommendations that's less than a page long, that tells you exactly what you shouldn't do. So if you just go download that document, read that one page, and configure the SSL server, you can deal with this one issue. Of course, configuration is just one part of it. Having your software patched, that's very important, especially because recently we've seen some of these attacks against SSL implementations. And approximately from here, there's only one last point to make about incomplete certificates. And it goes back, it's similar, it's a parallel to the DNS resolution discussion. In every certificate, you're supposed to list the domain names the certificate will support. And here on the screen, you have an example of Twitter, who have just recently purchased this, just on the 11th of May. They purchased this nice, shiny, extended validation certificate. And that's very good, because that will provide assurance to their users. However, what they didn't think about is that they've only made the certificate valid for twitter.com. And in particular, this is a very unusual situation, because most websites are used with a www prefix. And Twitter is one of the rare sites that actually do not use this prefix. So if you type, as I do often, HTTPS, then www.twitter.com, you actually get a warning, because this certificate is invalid. The problem is, and the online tool will warn you about this, the certificate is not valid for Twitter or www.twitter.com. So this is another example of money wasted and people being confused. In most cases, the situation will be opposite. The certificate will be valid for www variation, but not for the domain name without the prefix. So you can say, I guess that you can see the pattern by now. All these things are very simple to deal with. You just have to know about them in advance. So when you're getting your certificate, you just need to ask your certificate authority to include both domain name variations. If you will be using perhaps a third domain name, a certificate supports that, and you can actually have that third domain name in the certificate, and by doing that, you will avoid all the possible confusion with your users. The remaining points in my presentation are more about development and ways to subvert SSL from within web applications. And number 7 on my list is mixing SSL and plain text areas on the same website. So I mentioned SSL strip as one of the Moxie Marlinspike's tools. And the issue with mixing the plain text access and SSL access is that everything that goes under plain text can be completely subverted by an active man-in-the-middle. So if you haven't really thought about man-in-the-middle attacks before, on any unprotected wireless network, on a local network, if you have an active attacker, he can redirect all your traffic to go through him, and he will see all your plain text traffic, and he can even modify it. And he can even act as a proxy and change, only let you see the traffic that he wants you to see. And the issue is here, if you go to a website using plain text access, at that point, the attacker will completely hijack your traffic and your request. And if that website has a link that takes you to a secure portion of your website, what the attacker will do, he will just strip the secure portion of the link. And he will, instead of when you click on the link and request that you go to the secure website, the attacker will silently redirect you to go to the plain text website. And you will still remain unprotected. And if you're not really paying close attention, which can be quite difficult over time, you may even skip the secure part altogether. So that's why, in general, the only way to properly secure a website is to make it 100% SSL. Now, there's a technology called strict transport security that helps with that, and basically that allows you to allows a site to say, I only want to support secure access on this domain name, and you should never ever make any non-secure request for my domain name. And basically, that's the best thing you're supposed to do. The best thing is, if you have to have a plain text variation, you just do one thing, which is redirect the user to a secure version and use this secure strict transport security feature to tell to the browser to, from that moment on, forever continue to use the secure version. So, if you're wondering what you can do today, there's one point to make about secure bookmarks. So, if you have an internet banking website that you need to access when you are in potentially insecure areas, the best thing to do is make a bookmark in your browser to the secure version of the website, and always use the bookmark to go there. Never type the domain name in your browser, because that will usually go to the plain text version, and then the attacker may actually hijack that. Going to number 8 is a pet peeve of mine, which is using SSL for the important bits. There's a bunch of sites that will only use SSL for authentication, and they will help you to preserve your password. But the thing is, I don't really care about my passwords that much, because even a passive man in the middle will get from this. He will get my session. And with my session, he can completely take over what I do on the website. So if I want to post a blog entry from this conference here, someone will take over my, I use a service called TypePad, which is insecure. They only use SSL for authentication. So if I try to use to post a blog entry from here, someone on this wireless network could take over my session and publish anything they wanted on my blog. I don't really care about my password, but I really care about my reputation and whatever other crap and malware some bad guys will want to publish on my blog. So that's a big problem. Again, it goes back that the only way to properly secure a website is to have it 100% SSL. Number 9 is not using secure cookies. Cookies are generally used for session maintenance in web applications. And the thing is, unless you explicitly say that the cookie must be secure, and when you do that, what it means that the cookie will only be transmitted over SSL. Even if you have a website that doesn't have any plain text resources at all, there are ways, and there's a researcher paper that was published a year or so ago, there are ways for attackers to exploit the way browsers function and to retrieve that cookie even if you're not actually transporting it over the network. But the matter of fact is, many websites use insecure sessions with insecure cookies, and you will see these cookies just flowing across the network. And if you're a man in the middle, you can grab one of these cookies and just steal the session, and you have the same thing as before. And finally, number 10 is also a big problem, is mixed page content. So I already mentioned the previous one, where you have insecure plain text content and secure content on the same site, but I was talking about two different resources, two different pages. This is the extreme variant, where you have, within the same page, you have some resources, because if you think about a page, it's not a page, it's actually a collection of resources. There can be dozens of links. And the thing is, if any one of the links on a page is insecure, or rather retrieved without SSL, the man in the middle can hijack it. So if there's a link, and which is quite common with mashups, you will have some JavaScript delivered from perhaps a different domain name. What an attacker can do, take the JavaScript file and inject some